morning, and my apologies for speaking English. My children. I live in San Francisco, and my children are being raised French. They go to the École Bilingue, the French school, which is the best bilingual program in the world. Thank you very much, French government, for subsidizing the Francophone program around the world. And we thought that we would be able to, speak French to our children, but they won't let me speak French because they say it hurts their ears. They say, "Dad, you're not meant to speak French." So I will forgive you. I will spare you all of that. I think this is my clicker. I'm a geek and I am a boss. I run a division of a large media company. I have 2 startup companies on the side. I try to be a good boss, but I am a boss. I have hundreds of employees. But I'm also, but I'm first a geek. And I live in both worlds. I have to deal with the responsibilities of being a boss, but my instincts are all geek. And so what I'd like to talk about today is the sort of the dualism of these 2 challenges, the how to be a good boss in a world ruled by geeks, how to manage in a world ruled by abundance. And this is a little bit inspired by my book, Free, which is about the sort of the economics of digital technology and the consequences of that. But it's a very personal story because this is something I live every day, as do you. I'll start by just moving straight in. This picture here represents a moment. This picture is the opening of a nuclear power plant in Portland, Washington, the United States, in the 1960s. As you can see, the future was very bright indeed. This was the space age. It was the age of modern medicine and plastics, and the notion that technology would bring about a magical future where our needs were served by science, and that we would be full of leisure time and shiny suits. And the chairman of the Atomic Energy Commission at that time foretold that the coming age of nuclear power would bring about a day when electricity was too cheap to meter, that uranium was so plentiful, and nuclear power plants were so exciting that we would be able to create more electricity than we needed, and therefore you would not have to treat it as a scarce commodity. Instead, you could treat it as an abundant commodity. And indeed, the World Trade Center, RIP, the World Trade Center was originally created without light switches in the individual offices, because the idea would be that why turn off the lights? You could treat the whole thing like a Christmas tree. Just turn it off, turn it on. There was no cost to having the lights on when no one was in the room. And that exciting notion of technology's bounty, of technology's abundance, created the optimism of the 1960s and the space age. Now, as we all know, things happened. We discovered that electricity was not too cheap to meter. We discovered that nuclear power plants had costs that we were not accounting for. We discovered Chernobyl and 3 Mile Island and waste disposal and regulatory issues and transport issues, and you know what happened. But as a thought experiment, it's very interesting to think what would happen. How would today be different if Admiral Strauss had been right and electricity was too cheap to meter? Not to say free, but too cheap to meter, too cheap to treat as a scarce commodity, something that we would waste. I mean, just as one example, you'd have an electron economy, not just lights and heat, but imagine if you could desalinate water make fresh water too cheap to meter. And then think what that would do to agriculture if most of the inputs to agriculture, sun and water and air, or carbon dioxide in particular, if those things all became too cheap to meter and the only costs were fertilizer and labor, then and land, then maybe we would be able to create to irrigate huge swaths of the country, or any country, that are not currently agricultural ground. And then we could grow biofuels, and we would not have gotten hooked on fossil fuels, and we would not have oil crises and geopolitical conflict around the Middle East, and climate change and all that. If only electricity had been too cheap to meter, we would have had a different energy future. And that's just one example. Now again, that didn't happen. But what did happen is that 3 other technologies, as important as electricity in the modern economy, did become too cheap to meter. Those 3 technologies are processing, storage, and bandwidth. I call those 3 technologies because they are 3 different technologies based on different physical properties. But all 3 are becoming, or have been getting too cheap to meter, and are reflecting those abundance drivers that we expected from electricity in the 1960s. The first guy, I think, to really understand why managing digital is different than anything else was this guy here. This is Carver Mead. He is many of you may know who he is. He's one of the founders of the semiconductor industry. He wrote the kind of original textbook on VLSI integration, and he was a professor at Caltech. And he was the first person, I think, to really understand the economic implications of Moore's law. And that was that if, as you know, Moore's law creates, doubles the amount of processing power for a given price every 18 months. And what Carver Mead understood is that the corollary of that was that the cost of a unit of processing power would fall by 50% every 18 months. And that would continue. At the time he observed it, Moore's law had been running for 20 years. It has now been running for 30 more years. And we now basically look like we're going to have another half century of Moore's law at least, where the cost of computation falls by 50% every 18 months, 2 years. If something is becoming too cheap to meter, Carver Mead said, you should stop metering it. And by stop metering it, what he meant is you should stop treating it like a scarce commodity and conserving it, and instead treat it like an abundant commodity and waste it. And so he said, waste transistors. And he to his students, he would say, your job as you go into the world, riding the tide of Moore's law, your job is to find new ways to waste transistors. And they had no idea what he was talking about. How do you waste transistors? Do you pave roads with them? He wasn't sure. This guy here, Alan Kay, who was then at Xerox PARC, I think was the first guy to really figure out how to waste transistors. And I think most of you know who Alan Kay was, but one of the founders of the modern computing paradigm, including the graphical user interface and the Dynabook and all that sort of thing. But what he did is he looked at the computing paradigm of the day, which is the mainframe, and he recognized that this would be a good place to waste transistors. Now, this is what computing looked like in the 1970s. It was mainframes run in a glass box behind locked doors by the IT guys. If you wanted to run a program on a mainframe in the 1970s, you needed to ask the IT guys for permission. And you would submit your punch cards through a slot in the door, and they would ask you what the program did, whether it was mission critical, whether it had business utility, whether it was whether it was going to crash the computer, crash the mainframe, whether it was make efficient use of these expensive resources, these mainframe computers. And if they thought that your program satisfied their definition of what a acceptable use of the computer was, they would run your program, and 2 days later, you would get your error messages as a printout. Some of you may remember these days. They were bad days. And what Carver Mead realized is that a good way to waste transistors would be to take computing away from the IT guys. And the way to do it would be with this, to waste transistors on cartoons, on the user interface, to waste transistors on doing eye candy that would make computers easier to use and would eventually lead to the modern graphic user interface. The point was, waste transistors to open computing to more people. If you make computers easier to use, you take them out of the glass box into our lives, and then we figure out what they're for. And by mainframe standards, this is incredibly wasteful. I mean, the supercomputer, the 1970 supercomputer worth of processing simply to make these transparencies and reflections and animations, it is, no useful work is being done. And yet, it's essential to put computing in the hands of regular people. So that's wasting transistors for a good reason. And this picture, I think, belongs on the wall of every technology company somewhere. This is a picture of the first home computer. It is the 1964 Neiman Marcus catalog. It's a big department store in the United States. And the cover of the Neiman Marcus catalog was the Honeywell home computer, which was first available for $10,000. And when you look at this picture, you see what the technology industry gets right and what they get wrong. What they got right was that they understood that Moore's Law would bring about a day when computing would be cheap and small and even stylish enough to belong in the home. You could imagine that the costs would fall and the size would fall so that a home could afford a computer. What they got wrong was why anybody would want that. And they could not think of any application for computing in the home. So they convened focus groups and whiteboarded and brainstormed, and eventually they came up with one application, which was recipe card management. And so as you can see, this computer comes with a built-in cutting board, so you can chop carrots while you're reading the recipe. Now, it's worth noting that the input to this computer was hexadecimal toggle switches, and the output was hexadecimal lights. So the housewife of the future would have to speak fluent hexadecimal. It's also worth noting that not a single one of these computers ever sold. But today, when you reflect on what did happen, you realize that, of course, we do have computers in every home, and our pockets and our backpacks, and we carry computers with us everywhere. And the one thing we don't do with them is recipe card management. What have we learned? We have learned what the technologist's job is. The technologist's job is not to figure out what technology is for. It is our job to make technology cheap and easy and ubiquitous and put it in the hands of regular people so they can figure out what it's for. We, the technologists, invented TCP/IP and HTTP and HTML, but the world created the web. We created the technology, the infrastructure, but everyone else figured out how to fill it. And all those applications that came out only came out because technology was in the hands of regular people who had their own ideas and their own needs and their own context and their own power to use the technology to solve their own problems. And in the course of millions of people using technology to solve their own problems, we explored the potential space of what computing could be, and we discovered things like, like video games, for example, in the home. We discovered, the beauties of the web, blogging, Facebook, social networks, etc. This was done by putting technology into the hands of regular people and letting them teach us how to use it. There you go. Thanks, guys. My billing relationship is not with my wireless carrier. My billing relationship is with Apple. So in some sense, Apple has become the new carrier in that respect. And the importance of a billing relationship is as great as ever, but it's just shifted to a different company in a different industry. Now, as a producer, we have an iPad app and we sell via the iTunes store. As a producer, I have mixed feelings about this. I'm glad that the billing relationship is simple and easy, and there's a one-click solution, but I wish I didn't have to give up 30 cents on the dollar for it. And so I think you're going to see that one of the next battles going forward is going to be over billing relationships. You know, you've got the carriers, and they would like you to sort of, you know, to be the billing provider of default. You've got the new carriers, you know, Google, Microsoft, Apple, et cetera, and they would like to be your new, you know, the billing relationship of default. Then you've got the services like Facebook and PayPal, and they would like to be the billing relationship of default. And I think the new battlefield is in fact the transactional systems that it'll take friction out of spending and allow people to have this kind of one-click experience that telcos and Apple have traditionally done so well in the past. Okay, we have lights, we have sound. All we need is pictures. You said it's about 2 minutes to get the. Okay, 2 minutes, and then we'll have pictures as well. Yes, sir, over here.
Yeah, back to your paradigm, too cheap to meter.
Yeah.
Can we avoid metering because it's too cheap, or because the fixed costs represent 90% or maybe 99% of the total cost? Is it different?
Yes, absolutely. So too cheap to meter does not mean free. Too cheap to meter, because you're absolutely right. The fixed costs are very much non-zero, and the marginal costs are also non-zero but falling. So too cheap to meter doesn't mean that it doesn't cost anything. It means that it doesn't cost. The marginal costs are not high enough to pay any attention to. So typically, there's lots of ways to solve too cheap to meter. One is flat fee, right? You just basically sort of say it's you can use all you want, an all-you-can-eat service, which we see now in ISPs. Another way to solve too cheap to meter is allow someone else to pay for it. So, for example, the internet. You know, we typically don't pay for content on the internet because somebody else is paying for it, often through advertising. So, in other words, the incremental cost of a YouTube video is so low that YouTube doesn't charge me for it, and that a third party, the advertiser, can pay for it. And that comes out of the media industry. So, broadcast was another example of an industry that was too cheap to meter. It doesn't. You know, when you add another listener to a radio station, another viewer to a broadcast television, there's no cost. It's all about fixed costs. And so, although the cost of running the station is non-zero, the marginal costs are small enough that a third party, the advertiser, can pay for it. Yes, sir, back there.
An argument has been made that search engines are backing the trend of the long tail. What's your opinion about that?
Can you, I think we have sound here. Could you repeat the question with the microphone? With the microphone there.
Okay. An argument has been made that search engines are backing the trend of the long tail.
Yeah.
And I was wondering what your opinion was about that.
So it's a good question. There's two things going on with search engines. One thing is, you know, so first of all, search engines are a perfect example of the long tail. And if you look at searches right now, I think the number one search, and you can, I guess what it is, the number one search, you know, I think represents, let me put this another way. 40% of Google's searches every day are terms they've never seen before. So most of search is the long tail because everybody searches for something different. So search engines are a huge driver to long tail because we express our individuality in our searches, and we all have different needs. So that's the pro side. The con side is that to the extent that search reflects popularity, it tends to create this sort of snowballing effect where the popular get more popular, and you get these these network effect reinforcement. So that's not so much search as it is things like the most popular lists on Amazon, the most popular subjects on Twitter. Those things tend to kind of fight against the long tail by making the popular things even more popular. And so I think you see these two things going back and forth. Sometimes network effects amplify popularity and make the hits bigger, but the internet and search in general amplifies the internet and search in general enables the individuality of the population to show itself. And so I think what you find is that in short term you get these the popular become more popular, but they tail off very quickly. The popularity lasts very briefly. And so you get this churn through the top 10 list much more quickly than you saw in the past. Bigger hits, but shorter hits. Okay, I think we may have all of our senses now re-enabled. This is actually even where I was. So I'll start in again. Well, I guess we're waiting for this screen to come up, but I think you guys can see what's going on anyway. Storage. As I mentioned, storage is based on an entirely different technology, this magnetic and mechanical head technology. But it too is becoming too cheap to meter, and this is just a screenshot of the day when email became free. As you know, in the middle of the last decade, webmail was a big market. Yahoo was the #1 webmail provider, and Google was coming into the market to release Gmail. And the rumor was that they were going to release that Yahoo was offering, I think, 5 megabytes free, and then you had to pay for the rest. And Google was going to offer a gigabyte for free. And so Yahoo had to decide what to do. Should they stick to their model and continue to charge for anything above 5 megabytes? Should they match Google and offer 1 gigabyte? Or should they go all the way and offer infinite email forever for free? Now, the problem with that, going all the way, is that although it's obvious that's where the marketplace is going as storage gets cheaper and the sort of monetization of the user becomes better, they were potentially going to cannibalize their very lucrative market. They were going to sort of say, all those people who are paying us for more than 5 megabytes, you don't have to pay us anymore. And so it was very scary. They were also afraid that people would abuse the system and they would use their email inbox as a backup. But they had to do it. They had to do it because Google was coming to the market, and you couldn't just match Google, you had to beat Google. Now, it turns out that in the digital domain, it's often better to be small. So Google could say, we'll offer you a gigabyte for free, but because Google had no users, there were no fixed cost consequences to that. They could supply one server, put out a press release, offer the service to 10 beta users. Remember, Gmail was not open. You had to be invited to Gmail. And so they, with a very small fixed capital investment, they could put out a very big press release. But Yahoo, who had millions of users, for them to do the same thing would require a warehouse of servers and some real fixed costs. But they had to do it because this was a battle being fought out over an emerging space, and Google had the PR advantage. So what they did is they offered infinite email capacity for free, and two surprising things happened. First of all, people did not stop paying. First of all, the billing relationships was on an annual basis, and people were just lazy about it. They're not lazy, they just forget to cancel their subscriptions. And second of all, Yahoo was able to offer other premium services, like taking the advertising off, for those paying users, and people actually ended up continuing to pay for premium email. The second thing that they did is that they were able to cap abuse by simply saying that, look, email's free as long as you don't do any crazy stuff, right? So if you're uploading MP3s, we're going to spot that. And so by creating technology that would spot abuse, they were able to keep that sort of terrifying, notion of overconsumption at bay. And they also discovered there's a difference between old email and new email, and they could move the old email off their spinning disks onto tape or slow-moving disks overnight. And so they could move old email from their expensive servers to their cheap servers on the other side of the world overnight, and people would be absolutely fine if their old email takes longer to display than their new email. And so they solved the problem perfectly, but the consequence is that they set the market price of email to 0, which is where it is today. And, this quote at the bottom, your mailbox is full. I'll talk a little bit more about this towards the end of the speech, but, you may have had this experience where you come to work and you pick up your phone and, or you get an email and it tells you that your inbox is full. Your voicemail inbox is full. And, I had that experience myself. Like every month I'd come in and I'd get an email or a voicemail from my IT department telling me that I had to empty my inbox because I was using too much space. So everybody in my team had the same email. And, we'd spend our mornings sort of deleting old emails. So I thought about this for a while, and I said, I wonder how much storage we actually have. So I went to the IT department and I asked, my division is about 100 people, and I said, how much storage do we have for 100 people? And they said, we've got 10 gigabytes. I was like, 10 gigabytes? They said, yeah, absolutely. This is, we've put these limits in. It's been clear. We've been told you that we had 10 gigabytes, storage for email, and it's up to you to stop abusing it. Now, at that very weekend, I'd gotten a new PC for my kids. And as you know, PCs today come with a terabyte. 100 times more storage. My children had 100 times more storage than my entire division. And you sort of have, how does this happen? How did my IT department get stuck thinking that storage was expensive when my children know that storage is free? And the answer is that organizations get stuck. At one point, 10 gigabytes was a lot, and 10 gigabytes was like $40,000 worth of storage. And a policy was set in 1997, and that policy was never revisited. There were going to be storage limits. They were not going to add more storage at a rapid pace. Instead, they were going to push the scarcity to the users. And what we now realize is that we got it entirely backwards. What we were doing is we were conserving the abundant thing, which was storage, and wasting the scarce thing, which is the time and patience of our best employees. We were forcing them to delete emails because we got the equation upside down. Finally, bandwidth. As I mentioned, bandwidth is based on entirely different physical properties, that of photons and optical fiber. But once again, it's falling in price or falling in cost by about 100. It falls in price by 50% every year. The consequences now are wasting bandwidth. Now, what do I mean by wasting bandwidth? We'll take YouTube, for example. This is the sort of the canonical YouTube content of Lonely Girl 15, the sort of the viral hit. What YouTube is, if you're a television executive, what YouTube is a complete mystery. The traditional video production world has been built around the notion of quality. And quality is that scripts come in, ideas come in, you approve them, you put screenwriters on them, you get cameramen and directors and producers and audio engineers, and you make it great. You make it as good as possible. Great acting, great content. And people in suits decide what's good enough to broadcast. And then here comes YouTube, and YouTube says, it doesn't matter. Do what you want. Put it all up there. Cat videos. We will not decide what's good enough for video distribution. You decide. If it's good enough for you, it's good enough for us. And so people say, well, isn't it full of crap? And of course, the answer is yes. But your crap is not my crap. My home videos are of no interest to you. My home videos are of great interest to me. What I go to YouTube for is soldering tutorials. I'm a little bit of as I say, a geek, and I need to get better at soldering. You probably don't, or maybe you do go to YouTube for this. The point is that by wasting video capacity, by allowing people to put up crap, we are exploring the potential space of what television can be. Every video that can be made will be made. Every videographer who can be a videographer will be. Every potential kind of moving image will be put up there, and we will do a collective experiment in figuring out the future of television. My children are into Star Wars. A couple weekends ago, they said they're allowed 2 hours of screen time a week, and we said, okay, today, Saturday, you can have 2 hours of Star Wars on the screen. What would you like? Would you like Star Wars, the movies, upscaled DVD, big screen projector, surround sound, and we'll make popcorn? Or do you want to go to YouTube? and watch Star Wars videos made with Lego figures in stop action by 9-year-olds? And I mean, you know the answer. They went straight for YouTube. All children would rather go to YouTube than being forced to watch a movie. Why? Why? This is terrible quality, right? The children put their fingers in the picture. These are voiced over by 9-year-olds. You can imagine what it's like. It fails every test of Hollywood's definition of what good enough is, and yet it's exactly what my children want. So this word quality, what does quality mean? They don't know anything about quality. What they know about is relevance, which is to say that for 9-year-olds, they want to watch Star Wars as imagined by other 9-year-olds in Lego. George Lucas never imagined that the ideal form of Star Wars for 9-year-olds was going to be user-generated stop-motion animations created by other children. And yet that, in fact, turns out to be true. How do we know? Because we were able to waste bandwidth by allowing the experiment to run, by allowing all these things to get out there and then measuring their response. That's again how we put technology in the hands of users and let them teach us what it's for. This curve, for those of you who are familiar with the long tail, this curve will be familiar. This is the Pareto distribution. It's called a power law. And this sort of reflects internet economics. It is to say that some things are very popular, a small number of things are very popular, a large number of things are not as popular. And, you know, the 20th century was all about the left because we had limited distribution, and the 21st century is about both. You have the head and the tail because we can waste storage, we can waste bandwidth in letting these unpopular things get out there. And what's great about the tail is that that's the laboratory. That's the petri dish by which the new products of tomorrow will emerge as people experiment with, you know, the range of possibilities. The head is about scarcity. It's about scarce shelf space. So you go into a supermarket, a Carrefour or something like that, and they have limited shelf space, and the only products that are allowed to get out are those that are going to be popular. In Walmart, for example, a product has to sell twice a week in the average store to stay on the shelf. Most products do not pass that test, and so most products do not appear on the Walmart shelf. And if the Walmart shelf is the only lens you have into product variety, if it's not on the shelf, it doesn't exist. So the 20th century was one where we had this sort of tip of the iceberg. The tiniest fraction of possible products were available in the marketplace, and we could only measure what we could see. The 21st century, built on infinite shelf space on the internet, allows everything to get out. And you know, once again, we still have hits, but we also have the non-hits, and the collective size of the non-hits is sometimes as large as the hits. And so that's, you know, that is, as I say, the long tail, and you know that story well. But in the scarcity and abundance context, that's what enables the long tail, is abundant technical resources. From a management perspective, you have the same divide, the scarcity and abundance. You know, so scarcity in product availability is the shelf space. Abundance is the web shelf space. You know, in a store, in a physical store, you can have one mixer. In a virtual store, you can have every mixer. And what you discover, you know, just to use this one example of these mixers, what they discovered is that in the store, the number one seller mixer was white, and number two was black, and that was all they had. Online, you can have every color you want, and every year, the number 3 seller is a different color. And the number 3 seller sells a significant amount. 2 years ago, it was cobalt blue, then it was red. No one knows why it was cobalt blue 2 years ago. There's speculation that there's a celebrity chef who had a cobalt blue mixer, and that's why it was popular. No one knows. But the point is, we weren't able to see that. We weren't able to see the latent demand for cobalt blue mixers until we had a marketplace that had room for all colors. You know, scarcity is in media properties is the kind of the classic video store where it's just the hits. And you know, and on the online video store, Netflix is the example I'm using here. You have room for everything. The physical video store will have 3,000 DVDs. Netflix right now has 140,000 and more. And what happens when you offer this much choice is that you discover entirely new categories. So, for example, one of the categories here that turns out to be one of the most popular is gay and lesbian films. It's not pornography. It's just films with gay and lesbian themes. Turns out it's like the number 5 category in the independent films, which is a significant one. We had no idea it was that big. Traditional stores don't have that category. In shoes, for example, there's a store called Zappos, an online store. It's like now owned by Amazon. Zappos has more than 100,000 different kinds of shoes. And what they discovered is when you offer that much choice, you discover, again, categories you never saw before. One of the most popular categories of shoes is vegetarian shoes. Vegetarian shoes turn out to be shoes that have no animal products, no leather on their soles. Sort of like the Converse sneaker with a canvas sole is the perfect example of this. But it turns out there was a category. It turns out there was demand for animal-free shoes. And we only discovered it once we could offer abundant choice. In music, for example, of course, the record store is now dead. And the abundance here was predated, in some sense, the web. It was the storage on the iPod. Nobody asked for a device that could store 50,000 songs. Nobody knew they wanted a device that could store 50,000 songs. What Apple realized, and other companies like that realized, was that Toshiba and others were creating small disk drives that would have that much storage. So the abundant technology created the ability to release a product that could store your entire music collection. And once the product was out there, we were like, of course I want 50,000 songs. Of course I don't want to have to guess at what songs I'm going to want to listen to today. I want them all. And so the abundant technology surfaced a latent desire for all the music, all your music all the time. And that created a new category. To finish, I want to talk about the management aspect. This conference is about the management challenges and management opportunities of technology, geeks and bosses. And basically, I think of bosses being driven by scarcity and geeks being driven by abundance. Bosses have responsibilities and obligations. Bosses, our job is, and I'm a boss, my job is to conserve scarce resources. And that means money, time, brand, customer patience, things like that. So my job is to ensure that we spend our resources wisely for things that are likely to have a return. So in the scarcity model, when you think like that, you need if someone has a new product idea, you need a business case. An ROI memo is what we call it. How are we going to make money from this? The abundance thinking approach is like YouTube. We'll figure it out. Just do it because the costs are so low. And that's very difficult for bosses to handle because they're saying, well, what if it doesn't work? Well, the cost of things not working in the technology space is very low. Now, obviously, if you're developing technology, it's not low. But if you're just using technology, these are digital products being created using today's cheap and free tools, open source software, hosted platforms, the cost of failure is falling, and therefore you don't have to kill off ideas simply because they don't have a strong business case. Again, bosses have to say no. You have to sort of say, look, you can't do it until I say you can, because the cost of failure is high. In the abundance model, you can let everything happen. You can, again, be YouTube. Let all the experiments run, and only stop the ones that appear to be imposing a real cost, whether it's financial or otherwise on the company. In the scarcity model, nothing happens unless I say it happens. In the abundance model, we let the interns do whatever they want online. In my print magazine, where I control pages, which are very expensive, I am a total fascist. Nothing happens unless I say it can happen. On the web, where the pages are free, everything can happen. Anything can get out there. We have much different we have standards, but not the same standards. We don't ensure that everything's perfect right out. We ensure that we have a process to make it better over time as we get feedback. In the scarcity model, it's my job to decide what we're doing, and that whether I'm good at it or bad at it, someone's got to make that call, and that's my job. In the abundance model, we let the readers, we let the users, we let the community tell us what's popular. So again, in my job, I decide what goes on the cover. I decide the hierarchy of the news, how much space everything gets. I have to anticipate beforehand what I think is going to be popular, and I'm always wrong. And I would suggest that everybody who does this job is always wrong, sometimes in little ways, sometimes in big ways. We never get it right. If we had a 100% track record of inventing blockbusters, that would be amazing, but nobody does. And yet blockbusters are how we make our money. So we have to guess. But in the abundance model, you just throw it out there and you measure. And rather than me deciding the order of the page, we can let the audience decide through popularity what the order of the page should be. You get this emergent hierarchy rather than a predetermined one. The scarcity model, the entire concept of 20th century business structure is built around scarcity. This is top-down, management where it's all about responsibilities flowing. The buck stops here. Responsibilities flowing to the top, and therefore power flowing down from the top. In the abundance model, where the financial costs are so much lower, you can have bottoms-up organizations. You can have one where it's my job to simply look at the experiments out there and help the ones that are succeeding, amplify the success, suppress the failure, but not determine what gets out and what doesn't get out. Command and control. The 20th century business process and 21st is out of control. It is a very difficult time to be a boss if you've been trained in command and control, because you can't beat the crowd. You cannot get it right every time. You can't move as quickly. You can't imagine every possibility. Nobody is smart enough to figure out Steve Jobs aside, nobody else is smart enough to figure out what the marketplace wants. The out-of-control method is scary, it's messy, it's really kind of, worrying to see what will be done if all of your employees are allowed to launch products. And yet, through that method, you can be a much better boss. Rather than having to guess, you can measure. Rather than having to make a bet, you can simply reward success. One of my friends runs the company Automatic, which runs WordPress. Every one of Automatic's developers can ship. Every one of them has a button on their screen. They can write code and they can ship it right there on the spot. It doesn't have to go through a QA process. It doesn't have to be approved by anybody. Every developer can ship. Now, obviously, they can also unship very quickly when things go wrong. And so what happens is they can ship onto some of the servers and watch what happens. And if things are working fine, they can deploy it to more servers. If they're not working fine, they just reverse. They just undo the change, and that's very empowering. And when when developers are allowed to ship and get real response, they become better developers. That's out of control. It's scary. WordPress occasionally goes down, but it's a much better way to innovate. I want to end by just talking about the role of the CIO in all of this. Traditionally, the CIO has been the keeper of technology in every company. And the CIO's job was to sort of give you the technologies that you would use to do your job better. Today, it's not clear what the CIO's job is anymore. The university is a great example of the future of consumer behavior. Kids coming into university today are the Google generation. They have been brought up on broadband. They've been brought up on computing and cell phones. They understand technology better than we do. And so it's interesting to look at what a college student today wants from the college CIO or the college IT department. And the answer is toner. Printer ink. That's all they want. There's a couple other small things, but we did a survey of students at MIT. And basically they want a fat pipe and toner. They don't need the university to provide email. They don't need the university to provide, mailing lists or user groups or websites or anything like that. They can do all of that themselves. All they want is a fat pipe and someone to keep the printers working. Now, there's a couple other things that they like. If the university can provide some, high-end software and pay for the license fee, that's nice. If there's any kind of unique data, they can pay for it. But in general, that's all they want: fat pipe and toner. So the CIO used to be the one who would sort of, explore new technologies and deploy them and teach and all this kind of stuff. And now the job is to keep the lights on, right? To keep the bandwidth running and the toner flowing. Now, that is not you don't have to go to college to do that. That's kind of a janitorial task. And so, it's a real challenge. What is the role of it? So what does a CIO do in a university? And the simple answer is, they're not there to serve the students. They're there to serve the professors. The professors are older. The professors need help with technology. And so effectively, what they're doing is supporting a legacy customer base.